All right. Well, we'll go ahead and get started. Thank you all for joining us this morning. This is Theoris's webinar on artificial intelligence, hope versus the hype. I'm Jen Hawes, VP of Operations here at Theoris, and we'll be introducing our guest speaker, Benjamin Hall.
All right. Hello, everyone. My name is Benjamin Hall, and I am I'm the speaker. Purdue University grad, freelance developer. I've done this for a very long time. Software engineer and architect. Done a bunch of full stack stuff. Mostly, I'm a technologist. It's the best way to describe what I do. Winner of the 2008 Innovation Award at TechPoint, and got a lot of AI experience that's very broad, and that's what I hope to bring to the table today.
All right. And about Theoris, for those of you who aren't aware, we've been in business over 40 years, headquartered here in Indianapolis, Indiana, but do have clients on a national and actually international level as well. A couple of key areas for us in solutions is custom application development, code and architecture review, and data and management. We also provide a lot of IT and engineering staff augmentation, as well as quality and compliance. And some of our other service offerings do include IT project management, Q&A, and business process review. We are going to get started with the presentation. A couple of quick things. It is being recorded, and we will send out the slide deck after this, as well as questions. Love to have questions. You can feel free to pop them in the Q&A chat as you think of them, and then we will address all of the questions put in at the end of the call. So thank you very much, and we'll give it over to Ben.
All right. So let's talk about the elephant in the room. That would be AI. Everyone's talking about it. So let's give a little agenda what we're going to talk about today. We're going to talk about the current landscape. I'm going to go kind of in depth on generative AI and explain also agentic AI, what that means and what it is. AI in software development, which is really big right now. And I also want to discuss vibe coding, which is kind of a buzzword. You may not know what it is, you may know what it is, but is it real or is it risky? Let's talk about that. And then any questions you guys may have. So, welcome to the artificial intelligence age. Here's my meme for today, right? This is what people think it is, what it really is. So what do I mean by this? Well, artificial intelligence is not going to replace people. That is the big thing everyone's freaking out about. It's just a tool. There's no difference. If you look at the bush hog and what it did for a bunch of people out there mowing by hand, it makes life easier. And so AI is not going to replace people. It's going to make our lives easier. So let's talk about the emerging life cycle, technology life cycle, because that's really what we're facing today. When AI exploded onto the scene, it's a big thing. So we talk about the first phase, which is discovery. This is when we discover we have something and we're all excited about it. Everyone's talking about it. There's lots of media attention, and there are some small adopters along the way. Those are the early adopters. And then the buzz really starts to begin. Then we go into a next phase, which is often, I like to call it the blur phase. This is where there's a race to understand and control this technology or whatever. And there's massive attention now. Markets are moving up and down, that kind of thing. There's large scale adoption of said technology happens. And there's some panic. Some people freak out, and that's understandable. Then we move into another phase, which is the divergence phase. And the divergence phase is where we start to look at what we're doing and develop use cases out of it. This is where things start to bubble to the top and it diverges out of chaos and into, hey, we can actually use this for things. Technology then starts to standardize. We get used to the adoption, and it becomes more realistic, and the panic starts to subside, right? Finally, we get into the focus stage. And the focus stage is where we solidify use cases. We start to be more comfortable with it. Now it becomes routine, and adoption becomes ubiquitous. Everyone's doing it. And the buzz becomes boring, right? Focus is where we're actually moving toward. But we're here right now. We're currently moving out of the blur phase and into divergence. So let's talk about AI types and their roles. We started out with rule-based AI. And this may be familiar to everyone who's played any video game or, who has dealt with rules in a software application. It's created by humans. It's a matrix of of decisions that get run through said matrix, and it follows rules and simulates intelligence. That was the first iteration of AI. The second is predictive AI. And this is where we start to use algorithms to forecast things based on data and based on routines that we've had in the past. This is something that has become somewhat famous years ago when Microsoft came out with their machine learning techniques and things like that, but they're still algorithmic. The new kid on the block is generative AI, where generative AI uses models like large language models to make deterministic decisions and to generate content. And that's the big buzz right now. And then finally, we're moving into agentic AI, where AI is now making decisions and doing things autonomously or agentically, and completes tasks that way. So we're focusing on generative AI today, and with some focus on the agentic, but those are the types we're going to just keep that in mind. So what is generative AI? Now, when I first wrote this a few months ago, there was a massive panic, so I had to have this slide in there. This is kind of my humor slide, but there's a point. So it's not Skynet, right? Generative AI is probably uses probability matrices to predict outcomes of a given input. So what does that mean? Well, it basically just uses algorithms to generate text, and it uses techniques that in computer science we really haven't used until now. We didn't have the hardware, we didn't have the bandwidth, that kind of thing. So now we use words like machine learning, training data, chat, and that makes this more of a human kind of a thing. So it anthropomorphizes this technology. It's not human, it's not intelligence, it's math. But the way it works is similar to how I would say a lyric to a song, and then you might complete it when I stop saying it, right? It's really the same idea. So this little graphic down here is kind of saying, we need to, you start, and then the machine picks it up. Stop anthropomorphizing ChatGPT, right? So how does generative AI work? What is it? How did we get here? So let's consider GPT. Most people cut their teeth on Chat GPT. And so what does GPT mean? Well, it means generalized pre-trained model. Well, the training is the key point here. So in phase one of generating something like this, we have all of this data and we train this model. And I'll explain what that means in a second. And then phase two, we have a model, and then we can now use it by asking it questions. So phase one. So training data is fed into the program, and algorithms are applied iteratively. So this is just spinning and spinning and spinning on data. Weights are assigned to words. That's creating embeddings, and we'll talk about embeddings. So keep that in your mind as we go forward. These weights are also consider words leading and following to infer meaning. And then this requires a lot of time and data. That's why this is expensive. So let's look at this complex looking graphic here. So how are you doing? Goes into this matrix. That is your embedding matrix. And all it's doing is taking those words and it's adding weights all to these words, to these phrases constantly over and over and over again, and massages this data. Out of it, you get several weighted matrices. Now that's this WK, WQ, WV. And if you look a little bit to the side, there's keys, WK is key, WQ is queries, WV is values, that kind of thing. And all it's illustrating here is taking these embeddings and putting them in these matrices. And these matrices are actually multidimensional, meaning either two-dimensional, in some cases three-dimensional, and they lay over each other when you ask it a question. And that's how it determines what words to use to try to get back to you. So then we get into this phase two, and that's actually using a large language model. So the user runs his inputs through an encoder, and the encoder creates embeddings for you. These embeddings, again, this is just the math that you really don't care about. And then the process takes this context and transforms it into output through this predictive mathematics, all right? And it does that in the background again, layering those matrices over each other until it starts to figure out what you mean by what you say. And then it starts to predict the next word in the phrase. And it just does this extremely quickly. Now, context is king. What you feed it is key to what you're going to get out of it. And if anyone's used AI for a while, they know that there's a smart zone and a dumb zone of AI. And that has everything to do with context. So the more context you feed it, after a while, it starts to kind of get a little bit funky. And we'll talk about ways to mitigate that later in the presentation. So for now, that's how this works. So let's talk about what generative does well, right? It's pretty good at writing code and debugging code, writing unit tests, things like that, because code is not human language. Human language is very nuanced. Code is very precise. It's good at troubleshooting IT things. So if you've got connections and so on that it can read, log files and all that sort of stuff, it can read it a lot faster than you can. And that's good because that gets you to the problem more quickly. It's good at rewording emails. Some of us might have done that a couple of times going, make this angry note sound better. It's good at generating marketing content. When you have some ideas, you throw it down and you say, hey, can you expand on this? You can generate some more ideas there too. Brainstorming, it's really good with that. I use it for that fairly often. And breaking down complex information, analyzing data, and helping with creative writing and customer service chats. In fact, on the customer service chat, I had a problem with a keyboard at one time. I called in, got an AI, and the AI basically verbally walked me through the troubleshooting process until it finally gave me to an agent. But it was still pretty cool. So what does it not do so well? Writing entire applications. If you're like, write me an app that does X, it's going to create garbage. It doesn't infer content very well either, or intent, I'm sorry. You know how it is when people speak. Sometimes you have to ask them, like, what did you mean by that? Well, the computer won't ask that question. It'll just keep going, and that could be problematic. It doesn't automatically make the correct decision. Sometimes you ask it for information, and it comes back with something you really didn't want. It's also not good with real world understanding. Human beings have years and years of existence experience. The machine doesn't. It's just predicting words. So it doesn't understand seasons and things like that from an actual down-to-earth perspective. I mean, it understands what a season is definitionally, but it can't tell you, how wonderful the spring is or things like that. It can sound like it does, but it can't really do that. Aesthetics and taste is another thing. It doesn't have taste. It's a machine. So it's only going to give you what you give it. And it's also not consistent over time. Remember earlier I was talking about the smart zone and the dumb zone. Over time, it starts to lose its own memory and starts repeating itself or coming up with all sorts of things. And that's the next bullet, truth and reliability. It really doesn't know how to do that either. It's just predicting words. And we have a word for that. We say that it's hallucinating because that's exactly what it sounds like it's doing. Math. Yes, math. That typically shocks a few people when they start asking it math questions and it gives you some weirdness. It understands how to predict words and language. That's what it understands. So some of the greater mathematical ideas are not really, it's not really good with that. In fact, it has to use tooling in order to figure out mathematical computations in some of the tools like Claude and GitHub Copilot. But we'll talk about that later as well. The big one, though, is security and trust boundaries. How many times have you seen on various websites where they're saying, please don't give the AI your API keys or passwords or anything, because it will just happily leak that, no problem. It's not there yet. Now, we are writing certain safeguards to help against that, but it's best at this time that we just leave it to not handle anything with security or trust boundaries. And then again, anything outside of its context. If you didn't tell it, it doesn't quite understand. So what are the pitfalls of generative AI? And this is where a lot of the fear comes from, and I hope to allay some of that, but we still need to also know its weaknesses there too. Over-reliance on AI. that's becoming somewhat of a problem for two reasons. One, we still want human beings to learn. We don't want the machine to take over everything. And more practically, it's expensive. Tokens are not free. They're not cheap. And if you're blowing through tokens, AI tokens, it can be expensive for your organization. The other one is the belief that AI is intelligent. This was one of the problems we had earlier where folks were giving too much information or relying too much on AIs. There have been people cases in Asia where folks have fallen in love with an AI and they don't quite understand that it's not intelligent. So we got to be careful of that stuff. Just, be practical. Adapting AI too quickly. There were several companies in Silicon Valley who decided, hey, AI is here, and fired all their developers. They since hired them back. They realized that was a bad idea. Adopting AI too slowly. Some folks are very resistant, but unfortunately and fortunately, it's here to stay. So we need to embrace this and, find out where it fits in our organization and how to use it. Trusting AI output, that's a big one. Whatever it gives you, you need to read it and verify it because it has been wrong and it can be catastrophically wrong if you're not paying attention. So replacing humans, like I said earlier, companies tried that. It's a bad idea. We still need people. And then misuse of AI. Now, this is something that is emerging in the internet as well. People are putting fraud and crimes together at faster rates because those emails you used to get that were fraudulent and had a few words that were just not spelled right or so on, well, if they're generated by AI, they look much better. So we need to be more vigilant of phishing and spam attacks and things like that. And then finally, data security. Just be careful with that because an AI can leak that. So where are we on this modern AI stack? And this is important. We talked about layer one, the machine learning. That was 10, 15 years ago. Next, we had this deep learning. Deep learning is where we took this concept of a neural network and we're able to start weighting decisions and ideas and concepts, and that made things incredibly useful. Excuse me. This also led to the idea that we could use these same matrices to not only handle words, but to handle pixels in images, which led us to layer three, which is computer vision. Now these computers can not only hear our language, but they can look at a photograph and then cross-reference it very quickly with thousands of training data, millions of images and so on, and tell you what the image is. This has been useful for categorization and things like that. Also spotting fraud. It also generates pictures and videos, some of them quite amusing, some of them quite disturbing. So there's a lot of people out there that are concerned about, well, hey, if videos come out with AI, well, how do we handle that? Fortunately for us, AI has somewhat of a signature. If it's a bit too crisp, or if the guy has 6 fingers and a weirdness on his mouth and eye corners, you can typically tell what was generated by AI and what was not. But it does take some training to figure out, well, what am I looking at, and is it AI or is it not? But in this context, we're talking about the machine learning from the vision. And then generative AI. We have a climber. That's cool. Generative AI is what we're talking about now, being able to use large language models to generate content. And then because of that, we're figuring out when we get information back from it, how do we use that? How do we categorize that? And how do we categorize the information going into it? Can we capture that somehow and use it? This is where that grounding comes in, where we're using something called RAG, which is Retrieval Augmented Generation. What this basically means is being able to not only take data that we have and documents and so on, but to break that down into embeddings and then use that as information that the AI can go through and very quickly search and pull back and retrieve for you. And we'll talk about that in a little bit in depth here in a minute. And then finally, layer 6, agentic AI. This is where we have AIs that are actually doing work by themselves. Systems using reasoning loops. We'll talk about that in a minute too, to do tasks and do it agentically or by itself. If we have an LLM that we're chatting with, it can spin off several agents that do those tasks autonomously and then get back to the main agent. This has been something that the software industry is utilizing with things like Claude Code and with GitHub Copilot, and we'll address that as well. So here are some of the providers of AI, and this is just important to kind of let you know what's been going on in the world out there. I'm sure you've heard these names before, but it's important to know, who they are. OpenAI is for Chat GPT. They produce that. Copilot is Microsoft. Grok is X's answer to that. We also have Claude, which is Anthropic, their particular AI. Gemini is Google's. And there's some other guys coming out on the side here. Mistral AI is a French company, and they produce some of the open source stuff. You've got Meta, which is Facebook. DeepSeek is our Chinese our LLM that's out there. Perplexity is also an American company as well. And then you've got Hugging Face, and I put that in there for one reason only. All of the experiments and the open source stuff is on Hugging Face, and Hugging Face is got all sorts of stuff for the casual LLM experimenter, but the larger companies are the ones that are producing more useful things. So just keep that in mind for future reference. So if you do ever want to get into actually dealing with the LLMs themselves, they're rather large files. They can be run locally on your machines, but they require powerful machines and graphics cards. The reason for this is because your regular machine has a CPU. CPUs will take one instruction at a time, and they do it really fast. And if you have like 8 cores or whatever, it can take 8 instructions at a time, but it's still one instruction at a time. Graphics cards, they process data in parallel. So you've got entire streams of data going across the chips. That's why it's much faster, and AI works very well with that. That said, Anthropic uses more of a closed source thing, so it's very hard to get a hold of their models. They're very closed and licensed, which makes sense. So when you look at their files, you're going to see it as almost as if you're looking at a computer program with its entire language of what it is, its version, and when it was created. Others are a little more free, like Microsoft's Phi or Phi. When you do see their naming conventions, you'll start to see they've got version numbers, they've got the model name, but you may see words like instruct or a mixture of experts, and it's like, well, what is that? That's its fine-tuning attribute, what it was actually trained to do. If you see anything that says instruct, that basically says, oh, it's good at following instructions, right? Mixture of experts, we'll talk about these things a little bit more, but those would be things of like compartmentalizing tasks inside the larger LLM. And then here they may have this 128K or 128K or something like that. That's the context text window size. So this is how much data that it can hold in its memory at any given time and process over. And we're finding that bigger is better, but there's still a smart zone and a dumb zone. Just keep that in mind. Finally, you have more open source things like Qwen. Qwen has in its version number, its model name, and so on. But you may see something like, 4B, 3B, 32B, something like that. Well, the B stands for billion, and that literally is how many parameters you can put toward it. It can understand and process, in this case, 32 billion pieces of input. And then you've got your fine-tuning instruction. So if you're ever looking to play around with LLMs, you'll see these types of naming conventions and their numbers. Unfortunately, it's not standardized, but those are the kind of things you look for. So let's talk about RAG, Retrieval Augmented Generation. Traditionally, databases have been transactional, right? So you create something where it's like, oh, I want to do an order. It creates the order and it pops it in the database. And when you say, oh, I want to see all the orders from last month, you're going to get a list of them. It's a transaction every single time it addresses the database. And the data that goes into a traditional database is human readable text. So the only thing we've had the ability to do is search against it using text searches. which have been fine. And there's some other ones too, Elasticsearch and whatever, but for the most part, over the longest time, it's been text. The vector database is what is starting to come out now in the AI age, because the computer that's running an LLM, it can read text, but it understands embeddings a lot faster. So why not just store the embeddings in the database rather than the text? So that's essentially what a vector database is. It stores AI readable content and AI searchable content. And let's talk a little bit about embeddings. We've been talking about it, and it's kind of like, all right, I kind of get what you're saying. There's some math, whatever, but what's an embedding? Well, all an embedding is using these words and phrases and so on and assigning weights to them. In this graphic, you can see that you've got this living being column, and we may set weights to cat, kitten, dog, um, houses, that sort of a thing, and different weights to different things, feline, human, gender, whatever. And these can go on for, a long period of time, and just there's lots of data, in other words. Then they dimensionally set these things out. So again, when I talked about a two-dimensional kind of graph, that's literally what's going on. They're using numbers and weights on these matrices, but it kind of groups together, cat and kitten would be closer together than like, a dog or a house, right? Also, it handles connections between related concepts as well. So men and women are both human. So you've got this kind of a link there, and king and queen are related because they're both royalty. So those are the sorts of connections that these matrices use in embeddings. And embeddings are all about meaning and intent. And that's key to understanding how RAG works. So if we're going to retrieve data, first we have to have data. Typically, RAG databases are on-prem databases. A lot of folks don't want to just share it out into the web unless there's lots of contracts and so on. But they take their private data, and it could be anything. Think data lake, documents, PDFs, anything, emails, and they feed it into the system, and it breaks it down into these chunks. Now, it has to break them down into chunks because, some files are enormous and they would be out of the context window of the LLM that's processing them. So it breaks those chunks down into these embeddings and then goes through the LLM to get the embeddings first and then puts them into the vector database. Once that information is stored, now we can start to ask questions against it. We can query that data. We query the LLM, and then the LLM queries the database on our behalf. Once it retrieves the documents, it spins through them and says, all right, well, these aren't useful. And it starts to eliminate things until it gets a smaller, tighter context. Because again, whatever questions you're asking are in the context too. So whatever you're asking has to fit in with the data context that it derives from the search. And that gives you enough context for it to be useful to you. Otherwise, it starts to get and drift into the dumb zone and you get a bunch of garbage. All right, so that was RAG. Let's talk about agentic AI. The capacity to act or means through which something is achieved. Human beings have agency to change their circumstances. So agency literally is doing it yourself, the machine doing it itself. So out of agentic AI, we've got models that have been tuned to do reasoning, vision, and using tools. These three aspects allow for agentic AI, because if you start asking an LLM questions and getting things back, that's one thing. But if you really want it to solve a problem, it has to think about it. So it'll often go into a loop where it's reasoning about what you said to smash that context down into something usable. It can also, you can take a picture and say, hey, look at this photograph and tell me, what about it? And it can use its vision models to break that down. And then, of course, it can also call tools. Now, when I say tools, it would be something like, hey, can you tell me how many flights are going to Chicago this week? It uses a tool to make a web search, goes out to the scheduling app or whatever, pulls that information back and then hands it to you. So that's agentic. It's doing all that on its own. So how does agentic AI work? Well, it uses what's known as a react pattern, reason and act, right? First, you give it information and it reasons about that information. It observes, gets the information into a format that it can use. It thinks about it and makes a decision on what to do next. Now, this is a loop, and so there is a type of agentic AI known as human in the loop. So somewhere between 2 and 3 is usually where human in the loop ends up. So it might think about it, decide what to do next, go, am I able to do this, sir? And then you can go, yeah, go for it, or hey, what are you doing? So you can interrupt said loop. It then acts using tools, whatever it needs to do to complete the action. It reflects on that information that it gets that into a usable format for you, and then returns it to you. Now, we're back at step 1. If it still hasn't completed the task you ask it, it may take another trip around the loop, or as many as it needs to give whatever information you need. So that's how the React loop works. And if we compare and contrast the chat versus React, in the first graphic here, the basic responder, this is the typical chat GPT. You query, you ask a question, it hits the LLM, and then the LLM gives you a response. The React pattern, then in contrast, you take the query, it hits this agent. Now this little, the pink region is the actual agent. And that's where we're doing the loop, and we're spinning through it. It may use tools, it may do whatever it needs to do, and then comes out with its answer and hands that to you through a response. Typically, you would be interacting with an LLM, not the agent directly. And the LLM might spin off an agent to do something for you, and then the agent responds through the LLM. It may spin off 2 or 3. It may spin off any number of them to get the job done. So that has become a huge time saver rather than just the typical wait for a response from an LLM and then you are the loop, right? Excuse me. So let's talk about LLM types real quick. And I'll try to get through this fast just because this is still evolving. Let's put it that way. I recently added these slides because it's changed that much since I started writing the presentation. So GPT, we talked briefly about that. That is a generalized pre-trained. You give it information, it thinks about it, gives you information back. Mixture of experts, I mentioned that before. These LLM files are large. If you get a really quick and fast, lean one, they're like maybe 3 gigabytes. Some of these things will span terabytes. It's ridiculous. So to mitigate the problem of having all that in a massive, memory, the mixture of experts pattern was used. And that basically says, hey, we're going to take little slices inside of this LLM and we're going to break it off into expertise. And those expertise gets hit by a region for your questions. Instead of loading the entire model up, it loads pieces of it, which is pretty neat. We have large reasoning models. Now that reasoning has become more of a thing that models are able to do, they're kind of going wild on it. And there's some frontier models that are doing amazing work in reasoning. One of them would be Claude Opus. If you've ever worked with that, vision language models, I talked briefly about that. These are the ones that are able to analyze images. Some people are using them for analyzing fraud in banking, things like that. They can find the errors pretty quickly. And also they use them for categorizing images, things like that. This is a new trend coming out, the small language model. This is why it's like, well, why do we need this huge thing running in the cloud? Can I run it locally on my machine? Yes, you can. And if you have it with a very specific intent, it can run locally to great effect. Some people are using this for privacy, especially if they've got all sorts of sensitive data that they don't want running across the wire. They'll implement a small language model or several of them in their network and hit a very specific task that way. So that's another one coming. Large action models, this is where we start getting into agentic work. Large action models are ones that can do a whole lot of a single task very well, and using environments and all that sort of thing. So it's more of one that focuses on a larger memory footprint. Next, we have the hierarchical language models. This is what I was talking about earlier, where you're dealing with a language model that spins off other processes. And those other processes then are agents that do their things. So there's a different kind of hierarchy there, or architecture there. And one of the newer ones is the large concept models. This is where they're focusing more on the embeddings and really, really spreading it out to get research concepts and large, complicated human thinking into a machine that can be queried effectively. So colleges and universities are really all over this one because that's helping the research process of new technologies and new discoveries. So here's the big one, software in development, okay? Like I said earlier, we're talking about text, and code is text, and LLMs do a great job with text. And code can be predicted with a high degree of accuracy because, again, it's not English. I mean, it is, but it isn't. It's machine language, so it's a smaller set of words and concepts. Um, so that's why it's less nuanced. The bad part is that it can only work with the context it has. And so if you try to load the entire code base into your context, you're going to go real fast into the dumb zone and not get a whole lot of stuff. So yeah, it has problems though with some of its context, and every single thing that it outputs, you can't blindly just go by it. You have to look at it, make sure it's doing it right, which is pretty good. And for all of those out there who notice that this is a dungeon with inventory and monsters and so on, you know, sort of a gaming thing, you're a gamer and you know it. So let's talk about Claude and GitHub Copilot. These are the two big competitors right now for the coding space. Claude has Claude and Claude Code. A lot of you guys that are in the more of the managerial space might be more familiar with Claude because it's more geared toward that sort of workflow of coming up with concepts, emails, content, that sort of thing. Claude came out with a Claude desktop, which is pretty dang useful. If you haven't gotten it, it's pretty great. I'd say get it. And the free version of it's pretty good. Claude Code is their paid version though. That's the Claude desktop has the ability to add projects, and in that project you can load it with context, documents. It has its own mini RAG in there, and it can help you brainstorm over ideas, come up with with concepts, content, that sort of thing. And it does that through artifacts. As you talk to it, it generates these artifacts, and these are Word documents, PDFs, whatever it is you want, web pages, anything. I was just fooling around with it once, and I created an artifact that gave me a small tool that just helped me with video aspect ratios, and it did it in like 10 minutes. So you can do things like that too. So let's talk more about GitHub Copilot, because this one is embedded in VS Code, and since VS Code is a tool that a lot of developers use, this is a good start. So in this little graphic, you're seeing someone asking a question, and the chat agent can not only answer your question, but can also alter files, which you're seeing over here. And you can decide, hey, do I want to keep the content you generated? Do I not? I'm going to look over it, etc. Very useful for quickly coming up with unit tests, things like that, documentation, etc. Also, Copilot is working alongside developers there used to be something called pair programming. Actually, there is still something called pair programming, but we found it very useful if you have two devs working on the same feature or so on. One of them's coding, the other's kind of watching and helping. This helps you do this as well, because one of the things that we run into is we may get in there and change a variable name, trying to keep that in our head as we do something else. Well, the machine's reading the page as you type, so it helps you go, hey, you forgot this one. Hey, over here, did you want to change this? And it allows you to very quickly make edits that you may have missed otherwise. It also does inference. Like here, we're turning a 2D point into a 3D point, and it immediately said, oh, do you want a z-axis? Hey, you got this distance function. You probably want to calculate the distance in the third dimension as well. So it can infer what it is you're trying to do and code alongside you, which is pretty great. The other thing it allows in GitHub Copilot is the ability to code in place. So as you're writing code, you can ask for explanations or tell it immediately what context you're in, and it can figure out how to generate whatever code you're asking it for. I use this a lot when I'm trying to do a really quick function. I'll say, hey, I need a function that calculates the ratio between X and Y, and it'll immediately do all of that, or whatever. The one I really hate is recursive algorithms. I can write them, they're just annoying. So if I ever need one of those, I'll hit this and it comes out with a pretty good iteration almost every time. All right, so let's talk about vibe coding. You might have heard the term. Vibe coding is the concept that we don't need programmers anymore. We can get the business analysts in there, the UI UX guys in there, and they can just talk to the machine and it'll just create an app. And the thing about that is, if you're prototyping or thinking about something, it works very well. So, but unfortunately, it wreaks havoc in the long term. And the reason for that is that BAs and UX designers are really great at their domain, but they're not typically understanding of the full architecture of a computer system. They may not understand, various the idea of keeping things in their own lane, so to speak, three-tier architecture, you name it. So you really need an engineer to understand that and to at least keep the machine on the rails. And the reason that this becomes a problem is that the machine is predicting the next concept or the next text. It doesn't understand the business needs. It doesn't understand what systems you're on. It doesn't understand what languages your team knows or runs. So it may just make wild decisions. Now, I've seen other folks who have come up with entire plans and so on that spell all that out, and that definitely makes the application more robust, but it still doesn't solve the ultimate problem. You still need an engineer that handles the code, because that makes it more sustainable. Let's put it that way. So let's talk a little bit about AI into the future. Right now, we're on the cusp of the agentic world, and it's exploding. And that's good news and bad news. Good news because there's all sorts of things that we're going to get out of this. Bad news is this because we're going to have a lot of instances where we're repairing things that agents did wrong. So until we really start to narrow down into the focus section of the continuum of releasing new technology, it's something we just need to keep an eye on. But the future will be more agentic. They're getting better at this stuff. They're writing better software to manage LLMs and getting better software to manage the context that is delivered to the LLM. In fact, Claude Code and GitHub Copilot, that's their main function. Their main function is to get the context wrangled, right? Your code, your ideas, your plans, whatever. It manages that. So they're getting better at it, and things will get more and more interesting as it goes on. Also, LLMs will get smaller and more specialized. We're already starting to see that with the small language models. A lot of people are not comfortable with just throwing it all out into the web and into the cloud. Trust us, bro. Yeah, no. I'm also seeing that they'll become more localized. NVIDIA has and I think it's called the Spark, basically it's almost like a NAS box, right? Where you just plug it directly into your network. And it has the ability to run whatever LLM model you want to load into it. And as a networked device, it is networked AI. It has its own interface and all of that sort of stuff. And you can ask it questions, you can send it entire conversations, you can send it, RAG data, whatever you need. And it does it all locally. So that stuff is on the way as well. So you're going to see the large, big companies in the clouds, your ChatGPT, your Claude, your Grok, whatever, are going to become less relevant over time, which is actually good for them because they're kind of overloaded right now. And then AI will become systematized infrastructure. I think more and more companies are not seeing it as a toy, so to speak. They're looking at it now as a tool. And that's typically the way things work. They go from an idea or a toy to a tool. And because of this, they're building systems that are using things like agents and vision and so on for security, for fraud prevention, for anything at all. I mean, even going through old emails and so on, archival stuff. You may have heard people who've had like AS400 mainframes and so on is getting all this data that's been there for like decades, and like we have no idea what to do with this stuff. Well, they're starting to feed that into AIs now and, parse out that data into useful archive data that can be queried against. So there's all sorts of things that are going on, but it's now becoming a part of infrastructure rather than, just kind of a novelty off to the side. I also see that smart tech will get smarter as we get closer and closer to getting the smaller language models that understand only what they need to understand. We're going to start seeing those going on chips and on your refrigerator. Who knows? Maybe able to tell you, hey, Bob, your turkey's bad. You might want to throw that out. I mean, you never know. But I can see that as something that is coming. And then finally, I believe that robotics are going to start to explode. We've already seen people like, well, X is doing things with robots. I'm sorry, Tesla and Boston Robotics are making automatons, which are pretty impressive. Also, things in Japan and China are pretty amazing too. When you start pairing that with AI and agentic thinking, then you can have robots that will be able to actually do things that are useful rather than just be a novelty. So obviously this is the end here. Like where are we? The hope versus the hype, right? We're talking about building systems now, not just chatbots. Also using specialized models, workflow automation. This is the stuff that's going to stick around. This is durable. Hybrid use of cloud models versus local models. Data storage and AI workflows through vector data warehouse, that sort of things. We're going to see that stick around. And then high value workflow automation is going to be that key. That's part of our hope. The cooling off of the hype now. AI is not going to replace people. One model can do everything is now starting to realize that's not how it works. Bigger is not always better. Not every LLM is just a chat box. And this whole benchmark theater of my model is better than your model, none of that matters. What does matter is it useful and how are we going to use it in our infrastructure? So those are the cooling off parts. So we still have hope and the hype is going away. So good news. So how can Theoris help? Well, Theoris can help with AI use training. There's lots of companies there who want to implement AI, but they really don't know how. We can help you with that. AI assessments. If you're already using AI and you're thinking, I don't think we're using this right, we can get in there and take a look and help you understand, oh, yeah, you might want to try this instead. And there might be things you haven't thought of yet that we can help you with too. AI project and workflow consulting, that's something that we're getting into. This is still so new and so fast. But we're definitely starting to help companies talk about how do we move into an AI workflow and then giving them the tools to do that. And then finally, development team AI tooling. This is the Claude and the Copilot stuff that we can certainly talk about. How do we use this effectively to generate the code that we're after? All right. Any questions?
So I'll pop back on. Thank you for those that have posted in the chat or sent in and just via Teams or other avenues. But we do have a couple of questions starting out with how do you protect proprietary or sensitive company data when employees are using AI tools day to day?
Yeah, that is going to have to deal with policy and blocking, unfortunately. I would create a list of the AI that they are allowed to use and stick to it, and then have your IT team, cut off anything else, right? And the other thing is to explicitly tell them what they are allowed to do and what they are allowed not to do. And that's a policy decision. Unfortunately, there's no automated solution for that yet.
Okay. Another question. What does agentic AI look like in a real business workflow today, not the theory side?
Sure. Okay. Well, agentic AI is used in software development. I use it all the time. And I use it to help me discover bugs and things like that. For a business use, it may do something like you may have just a boatload of documents that you want something to work on. You could put an agent on it to say, hey, look, whenever this folder gets another posting of a document, read said document and do something with it. And the AI agent can do that. But there's thousands. I mean, literally, if you can think of it, there probably is a way it can get done. It's just a matter of figuring it out. It's pretty neat. Agentic AI is pretty cool.
Okay, thank you. Another question says, great presentation. Can you give examples of Theoris clients who are successfully leveraging AI versus struggling, as well as what is the difference between successful and unsuccessful approaches? If you want to start that one, I can finish it.
Okay. The short answer is I've been focused on a single client. So I can't speak to the broader view with Theoris other than the fact that we do have people that are using our services for AI. In my area with my client, I'm helping to focus on how we use Copilot more effectively because that's the tools that we're using. And Jen, you can tell her.
Broader, can't name the names, but so far our larger clients, more of the enterprise accounts that have implemented AI, we have provided a number of resources to help them, mostly to automate bits and pieces of their applications. I think the ones we've seen struggling more are the small to mid-sized companies that feel that they are not progressing fast enough. We've had several clients have meetings saying, well, we want AI, but when you ask what's the business need you're trying to solve, or what have what's your thought process, they can't really say what they want to do with AI. They just feel like they need to do something so they're not left behind. So a lot of it is just working with the clients to figure out when you use it and when you don't and what makes sense. And I would also echo Copilot seems to be one of the more predominant ones at our client sites. But for additional questions and discussions, we can certainly have one-off conversations a little bit more in the weeds with that. But good question. All right, we can do one more unless other people in the group wanted to send an additional. I do have a couple of more here. All right, I'll go with one of these. What skills should I learn today to get ready for the next thing?
Excellent question. Excellent question. I would say that the number one skill that you want to learn is prompting the AI. How do I talk to it? Now, this depends on your role. If you're a software engineer, you're going to prompt one way. If you're marketing, sales, whatever, you want to prompt another way. Now, the prompting, it's kind of tough because you really just talk to the AI. That's all you're doing is just talking to it. The issue is you have to become a better communicator. That said, I would say yes, prompting, but communicate. Learn communication. How do I tell anyone instructionally to do something? What is important? What is not important? And then how do I do this succinctly in a smaller version of the said conversation? So prompting is the skill I would look into. You want to learn how to talk to the machine, but also you want to learn about what models are good for what purpose. And this is something that's kind of difficult to do, honestly. The reason I say it this way is because in the code generation world, there is the Opus from Anthropic, and then there's like the GPT-4 or GPT-5. If you're using everything on the Anthropic model, that's expensive, and it may not do as good a job for maybe just doing the basic coding. And if you use the cheaper models to do the large reasoning, you're not going to get the thing that you're after. So learning to use the right model for the right purpose is the other thing I would learn.
Okay. We'll do one final question, which I think kind of ties into that, is just what is your take on tools like GitHub Copilot versus Claude versus ChatGPT for day-to-day development work? Do you have a preference on which tool?
The short answer is no, but I particularly like using Copilot in GitHub Copilot because it's a little bit more customizable. I can tune it the way I want. Claude is useful for kind of hand-holding. It really holds your hand and takes you through said processes. So if you're the type of person that's like, I really need it all spelled out for me, that's fine. Use Claude. It does a great job. But if you're the one that's like, nah, I get it, I know what I want to do, and quit bugging me, well, then that's more of a Copilot. So me personally, I like Copilot because I can customize it, but I've used both, and both are excellent.
All right, thank you. Well, if there's no additional questions, I'd like to thank Ben for the presentation and all of you for joining us today. We will be again sending out this recorded version later today or tomorrow, and please let us know if you have any questions. Thank you all very much.